Hey guys, it's Brian, aka Krosik, and today we're going to be continuing our Phaser platformer tutorial. And what I'm going to be talking about today is how I've decided to structure the game in terms of handling the overarching logic of the game. And basically what I have everything set up as is having a main engine class that handles all of the logic of the game. And basically, so we discussed states of Phaser in our last tutorial video, and you can basically think of the engine as something that sits on top of the states and is able to see everything that's happened and remain persistent throughout all of the different states and be able to swap in between them and kind of control the states and what's going on inside of them, totally separate from the actual state classes. So what we're going to do here is set up the real early architecture of our engine class. And once we start developing it, I think it'll make more sense in terms of why it's useful and how it makes it easier to kind of control everything. So inside of our folder here, we're going to have our engine folder, which is going to contain all of the classes that have our actual game logic. And in the engine folder, we're going to be creating a engine class. And so this is the main engine that drives all game logic. So a couple things we're going to want to have a reference to in here. So this engine is going to have a ton of static variables that are able to be referenced throughout anywhere inside of the different phaser states and all sorts of different places. And so a static variable pretty much means that no matter how many instantiations of the engine class there is, there can only be one instance of that variable. So we're going to be filling all this out later, but we're going to build the kind of structure here. So we want to have a reference to the player controller. And the player controller is just the class that drives our actual player logic. So we want to kind of compartmentalize each of the things that are inside of our game that need some logic to be acted upon. So the player is going to be handling input and moving and handling collisions and stuff like that. So we want to break that functionality out to a separate class. So we'll create a reference in our engine here so we can reference them from other places, and we'll just call it the player controller. And this is going to be of type player. We, of course, haven't created this player type yet, but we will eventually. And we want to have a reference to the actual phaser sprite that is the player object. So the important distinction between these two things is that the player controller is one of the classes that we set up to actually control the logic of the player. The phaser sprite is the actual representation of the player on the screen, so if you want to move it or rotate it or anything like that, you're going to be acting on the sprite, not the controller that handles the logic. So we want to have a reference for that in the game as well. So we can just call that the actual player, and that will be of type phaser sprite. So we also want a main reference to the phaser game object, right? So all the states can access the phaser game, but we have to have the engine be able to reference the main phaser game as well. So we want a public static game, which is going to be of type phaser game. And so remember, in TypeScript, the syntax here with the colon just denotes that, okay, we're declaring a property of the engine class. It's called game. And what kind of type of data is game? Well, that's a phaser.game. And so that's how TypeScript does a lot of its compilation time, type checking, and all that kind of stuff, which is great. So for now, these are the only variables that we need to concern ourselves with. The first thing what we're going to be working towards is getting a player on screen and being able to move them around a little bit. And so we're just setting up our engine to be able to handle that. So we want to have a function to initialize the engine, and we can just call that static init engine. And the only parameter that we need to pass into here is the phaser game object. And so this will allow us to set up our reference inside the engine class for the phaser game to be equal, or to also reference the same object that the states have referenced, which is the phaser game object that they have access to. So all this is doing is letting us access our main phaser game from our engine class. And for our player controller, we want to instantiate what that's going to be. So we are going to be creating a new instance of our player. And like I said, we haven't actually built the player class yet, but this is where it'll actually get instantiated. And so that's enough for the instantiation of the engine for right now. And what we also want to have able to be called from the engine itself, right? Because we want, the main goal of the engine is to have all the logic flow through this class. And this class will hand out different functionality to different classes, but we have one centralized location that we can refer to for controlling the logic of our game. So having said that, we're going to want to expose a function for the engine to be able to initialize the player. And all this will do is our actual player will get set, the player reference will get set up, and we'll say here we're going to call the init player function of our player controller. And so you'll see this in a little bit, but all this is going to be doing is setting up the actual sprite of the player on screen. So remember, the player object, or the player variable or property inside of the engine class, is a reference to the actual phaser sprite. And the player controller is the actual logical controller that we've created that's going to actually handle the logic of the player. So it's a little bit confusing thinking of it with the separation that way, but once we start actually building out the logic and everything like that, it'll make a lot more sense as to why we have one property for the actual sprite of the player and one property for the actual logical driver of the player. The player sprite. Okay. Alright, so the other thing we want to do is be able to update the engine. Now, if you remember from the states video, in the game state, what we actually have is a function that gets called 60 times a second, and that's the update function. So normally what you would have to do here is check for the input, move things, check for collisions, all that kind of stuff. But from here, all we're going to do is actually just call our engine's update function. And from here, this will handle all of the logic of updating our game. So all the state has to be concerned about is just make sure the engine's running, and we can handle all of our logic inside of the engine. And like I said, the engine will be the class that kind of passes out different functionality to different classes and all that kind of stuff. So from inside of here, we're going to have a update function. And inside of the engine function, the engine update function, the main things we're concerned about is we want to be able to update all the components inside of our game. So for right now, the only thing that we're concerned about updating is the actual player. So what we can just say is the player controller, right, because that's the actual logical driver of the player, that's going to have an update method. We're going to call that. So this seems a bit redundant calling it this way, but it helps us keep things structured. And so the state calls the engine to update, and that's all the state needs to know about. There's the engine class, and that's going to handle everything. That's all the state needs to concern itself with. And then the engine is the actual class that goes and drives every component of the game, such as the player, and this will also expand to having the tile map having an update function getting called, any of the enemy functions, any enemy update functions that need to be called, all those type of things can be handled inside of the engine. So with this is actually all we need to do to set up our player and to be able to update the player. So now the main thing, of course, is we need to actually have a player class that's going to be the main driver of the player in the game. So we'll set up a new file, just call that player.ts. And this is going to be class player. Okay, and so the main things we need to have is the actual sprite in the game that is the phaser sprite. So we need to have a reference to that inside of our player class. Okay, and from there we're going to fill out the methods that we were calling inside of our engine class. So we want to have the init player and the update function here, right? So we want to make this a public function so the engine can call it. And we want to init the player. And so we're going to be doing some stuff with the tile map loading, getting our player from the tile map and stuff like that. But for now, let's just assume that we've loaded in an asset that's called player inside of our preload state. And so all we're going to do is we're going to reference the engine's game object, right? Because the player class doesn't have a reference to the game because it's not a phaser state. So since we've set things up for the engine to have a reference to the game, we can just go through the engine. And we want to say engine.game.add a sprite. So we're just adding a sprite to the phaser game. And we'll say it's at 200, 200, and the sprite's name is going to be player. So one of the other things we have to do when we initialize the player is actually add it to the physics world of the game. So add the player to the physics world. Because if you don't add this step, then Phaser doesn't know that physics apply to the player, and it's just going to let it go wherever and do anything. So what we want to do is just say engine.game. Oops, and actually one thing I forgot is we have set up our player variable for the player class, which is the sprite, and the sprite's getting created here, but we didn't actually store that as a reference. So we want to make sure that we set our player property to the sprite that's returned from this call to adding the sprite to the game. So to add this player sprite to the physics system, we can call the physics property of the game, and we're using the arcade physics system, so we're going to call that property and just say there's an enable method, and we want to enable it for a particular sprite. So all we have to do is this. And so all we're saying here is that this player sprite that we created and added to the game here, let's add it to the physics system. So now physics can actually be used on this object that's in the game world now. A couple of other things we're going to set up here for the player are things like having the camera follow it. So have the camera follow the player. And this is super easy to do in Phaser. Again, we're referencing the game object of our engine. And the game object has a camera property, which also has a follow function. And we want to tell it to follow a certain target, which is going to be the player sprite that we just created in the game. And then how do we want to actually follow it? And so in the Phaser camera class, there is a property follow lock on. And basically this follows it very tightly. And what we can do is give it a couple of small values for the lerp in the X and Y direction. And you can experiment with these values and see how it actually works, but essentially it just gives a little bit of lag before the camera starts following the player as the player moves around on the screen. So it doesn't seem so rigid, and it just gives a lot more of a smoother feeling to the camera following it. So one other thing that we want to do is make sure to check if the player moves out of bounds of the world. So this is just basically saying that this dot player, so the sprite that we've created, dot check world bounds equals to true. And all this is saying is basically we want to make sure that the sprite doesn't go out of the bounds of the worlds, which is out of the bounds of the level. And we'll get alerted if that actually happens. So we'll set up basically functionality to tell the game that the player died if it left the actual world. And so we'll set that up a bit later though. Alright, so the last thing we're going to do is actually set up the functionality for having player input. So one other property we need to add here is something to keep track of what keys we have in, or what keys are being pressed at the moments. And Phaser has something for that, which is very convenient, just by saying Phaser cursor keys. And this allows us to know if the left, right, up, or down keys of the keyboard are being pressed. And then we want to set that up here. Set up the input for the arrow keys of the keyboard. So we can say this dot cursors, and we want to just set this up. So it's basically telling Phaser to start listening for input on the different arrow keys. So the Phaser game, and there's an input property, which has a keyboard property, and create cursor keys. So this is just setting things up in the background for Phaser to know that, hey, we want to listen to if there's up, down, left, or right being pressed. And the last thing we want to do is once we've initialized this whole thing, we want to actually return the sprite from the initialization. And this lets the engine have a reference to it. So when we look back in our engine class, we can see that the player controller as a init player function is being called. And like we just saw, we're returning a reference to the actual Phaser sprite. And so this lets the engine have a reference to all the relevant things, right, that we want to know about. So the other function we want to actually set up here is the update function for the actual player. What we can do here is just check for some basic input from the arrow keys that we just set up and be able to move around our player. So what we can do here is we're actually going to set up a couple helper functions for inputs. And the reason we're going to do this is later down the line when we have gamepad input and keyboard input, it allows us to check for the input from either of those two sources with one function. So this makes sense in a second. So if we say is write down, so we're creating a function in private, meaning that only the any internal functions of the player class can reference this function. We want to be able to return if this.cursors, which is again the property that we set up for Phaser to know if any of the arrow keys are being pressed down. And then so this has got 4 different properties, and you can just reference any of them very simply, and you can say right is down. And basically this is going to just tell us, is the right key being held down? So in here we can say if this dot is right down, and this will be true if the right arrow key is being held down on the keyboard. And so again, the reason why we set up this helper function is because down the line when we do gamepad input, we can say something like if gamepad dot left dot down whatever, or this. And so we can have this function check for both of those inputs, and in our update function we just have to check this one method, or this one function, just seeing if right is down, then okay, proceed. So what we'll do here is we'll just say player.body. I believe position.x plus equals 2, whatever it is. So this will move it to the right, and we'll set up another helper function, is left down, and let's return the same type of way, left dot is down. So this is just checking if the left arrow key is down. So we'll say we can have it as a separate if check, left down, and we'll do this a little bit differently as we move forward, but so player.position.x minus equals 2. So this just moves the player sprite in the x direction, either 2 pixels to the left or 2 pixels to the right, based on if the right arrow key is down or the left arrow key is down. Now if you notice, just something to note, and this will all be changed in the future, but in the update function, both of these checks are going to be made. So if the right arrow key is down, it's going to move the sprite to the right, and then it checks to see if the left arrow key is down, it's going to move to the left. Now, just an important thing to keep note of is that if you hold both of those keys down, there's nothing in Phaser that's going to stop it from trying to move left and right. So you'll get some behavior where the sprite's trying to move left and right, and it actually won't move anywhere as long as both keys are held down, because it's going to be moving the same distance in either direction. So just something to make note of. So I've got the player image over here, and if we're just going to take it from our file explorer and drop it into the images folder here, we've got our player image inside of the assets folder. Now what we can do here is inside of our preload state, where remember we're loading all of our different assets, we're going to say this.game.load.image, and we're going to give it a name of player, right? And we're going to give it the path that the image resides in, player.png. And oh, this is actually an important thing to note. This is actually the incorrect way to do it for a sprite sheet. This works for a single static image, but for a sprite sheet, what we want to actually call instead of image is, you guessed it, the sprite sheet function. And so we still give it the same key, we still give it the location image, but what we have to do here, as you can see here, is give it the frame width and the frame height. So that lets Phaser know that this is the size that the sprite sheet should be sliced into. And it does all the work from there as far as slicing it up into individual images that you can use inside of the Phaser game. But you have to make sure that all of your different images in the sprite sheet are the same size, and then Phaser will handle the rest for you and set it all up. So now we've got our player loaded here, and inside of our actual player class where we're creating the player, we're adding the sprite, which has the name player. So that's all good. The engine is creating the actual player through the init player function being called here. And so we just need to initialize the actual engine. So we'll do that in our preload state here. So let's init the engine just to get things started. So the function we've already defined here, it's just we want to initialize the engine, and we want to pass it the Phaser game object, right? Because the engine wants to have the reference to that game object. So inside of here, all we're doing is setting with a reference to the game object and creating our player. And the player class is here, and we're creating the actual player from initializing the player, which we're actually, I forgot to, I think, add that there. Ah, that's right. So in our game object, instead of setting up our logo here, let's actually add the player to the game world. So inside of the game state, we're going to tell the engine to initialize the player. And so this comes back to the reason why we have the engine, right? So independent of each of these states, the engine persists, right? And is able to drive all the logic of the game. So the states just need to be concerned with what the engine exposes, and then the engine itself is the thing that drives all the logic of the game. So once this is initialized, it actually adds the player to the game. And in our update function that gets called from the update function of the game state, we're actually updating the player controller. And this should be listening, again, for our left and right inputs and moving the player accordingly. So we'll give it a shot, and we'll see how it runs, and we'll see what we forgot to do. Okay, so we're actually looking pretty good. And I actually didn't forget anything. So what's happening here? The Phaser game is loading in our player object at a certain location. It was at, I think, 200, 200, which, because we're scaling, actually scales it to 400, 400, which is why you see it kind of towards the bottom of the screen and closer to the middle. And what we're doing is we're listening on every frame to see if the left or right keys get pressed down. And all we're doing with that is if they're getting pressed down, we're moving the player's position left and right. So as you can see here, I'm holding on the left key, holding on the right key, and we're just moving our player in a constant velocity, either in the left or the right direction. And we could say here, let's just create, because we're going to need these. Actually, I don't know if we need these eventually, but we'll just say is up, down. That's kind of confusing. You know what? Let's just do it here and say if this dot cursors dot up dot is down, then this dot player dot position dot y minus equals 2, and if this dot cursors dot down dot is down, so these are just the up and down keys of the cursor keys, position dot y plus equals 2. And so because we've got our compiler watching for the file changes, it's already compiling the TypeScript into the JavaScript that we need. And the cool thing about Electron, I believe it's Control R, we reload the game. And so this reloads everything, of course, and we've still got our left and right. Now we've also got up and down, because those are the things we just added here in our update method. So now we've got a sprite on screen that we can move up, down, left, and right, and all the different directions based on the arrow keys that we're holding down. And one thing to note is that if you noticed, I have the Y position being incremented in a positive fashion when the down arrow is pressed. And that's because, and this is, I think, pretty standard in most graphics setups, the top left corner of the screen is actually 0, 0. And as you move down the screen, the Y value increases. And as you move across the screen to the right, the X value increases. So the bottom right hand of the screen is actually at 800 to 600 in our case. So that's why we want to increase the Y value in a positive fashion when the down arrow is pressed, and actually subtract from the Y position when the up arrow is pressed. So it's kind of opposite of what you're normally used to from calculus or whatever it might be. So there we go. We've got our player on screen and we can move them around. And from there, we'll go into things like setting up the actual tile map, setting up the actual physics for the player, because the physics aren't being used for the player. We're just moving them around at a constant velocity. So we'll actually get the game running properly. So moving forward, we'll go in and set up things like actually having the tile map be set up inside of the game, and actually having the physics system being used on the player, and all sorts of stuff, and actually getting a game being made out of what we've set up with our structure so far. So thanks for stopping by, and I'll see you next time.